I am Dr. Ramanuja, Assistant Professor, Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. Almost all I covered in these modules about mean value theorems and special functions. Especially, somewhat it is difficulty to remember the concepts of like a special functions. Further, this module I am further extending. This I think special functions in beta gamma function. This is module 3. In this module 3.5 module, further I am extending one more content. In this module, I will give the concepts of how to write the beta function into gamma function, and also using this beta and gamma function, somewhat complicated function like a logarithmic function. Sometimes it may be in the form of exponential function. In such a cases, how do you expand in this module? And also further I am going to use very important concept, proof of the relation between beta and gamma. This in this module I am going to cover, and also one more in this module I am going to cover duplication formula. How do you convert into gamma of n into gamma of 1 minus n with proof, with one example problem. Okay, let us go with the one more problem in the previous module continuation. Evaluate integral 0 to 1 x cube into under root of 1 minus x using beta and gamma function. Whatever we taken as a first kind of the improper integrals, we are converting into beta functions. Further beta function, it is to evaluate difficulty which are not an integer values. Further we are going to apply using the relation between beta and gamma. We are converting into single variable functions. This is an example problem I taken to evaluate, and this question may ask sometime, show that integral 0 to 1 x cube into square root of 1 minus x into dx, which is equal to 32 by 315. Let us go with this problem. See, actually this function, we need to identify this function should be an beta function. This is first of all, we need to understand concept of beta. Already I told beta is a function of two variable functions and gamma is also a single variable function. Let us take the given function. What is the given integral? Integral 0 to 1 x cube into 1 square root of 1 minus x into dx. I can rewrite this integral x cube into 1 minus x whole power 1 by 2 into dx. Already you know the definition of beta function. What is the definition of beta function? Beta of m comma n is equal to integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 into dx. We need to compare m values as well as n values. Okay, let me compare m minus 1. Let m minus 1 is equal to how much? 3. Therefore, m equal to 3 plus 1, m equal to 4. Similarly, n minus 1 equal to 1 by 2, n is equal to 1 by 2 plus 1, n equal to 3 by 2. n equal to 3 by 2. Now, I identify the value of, I need to convert this into m comma n. I can rewrite this is nothing but beta of 4 comma 3 by 2. Now we need to identify the value of beta of 4 comma 3 by 2. Now already we know the definitions of m comma n. M and n are the positive integers. I can calculate directly m minus 1 factorial into n minus 1 factorial whole divided by m plus n minus 1 factorial. Here n is not a positive integer. I need to convert this into, the using relation between beta and gamma. What is the relation between beta and gamma? Beta of m comma n equal to gamma m, gamma n by gamma of m plus gamma of n. Now I am converting beta into the gamma function, gamma of 4, gamma of 3 by 2 whole divided by gamma of 4 plus 3 by 2. This is nothing but gamma of 4 into gamma of 3 by 2 whole divided by gamma of 4 times to 8, 9, 10, 11, which is 11 by 2. Now we need to find out gamma of 4. Already in the previous modules, I discussed about how to calculate the gamma of integer values as well as negative integer values as well as positive integer value, except n is not equal to 0. There is a discontinuity function at the particular point of n equal to 0. Therefore, gamma of 4 can be written as 3 factorial into gamma of 3 by 2 can be written as 1 by 2 into gamma of 1 by 2 divided by gamma of 11 by 2 can be written as 9 by 2, 7 by 2 and 5 by 2 into 3 by 2 into 1 by 2 gamma of 1 by 2. What is gamma of 1 by 2? Root pi. I can cancel this gamma of 1 by 2. This 1 by 2 also gets cancelled. If I simplify, this becomes 3 factorial means 3, 2, 1 whole divided by 9 into 7 into 5 into 3 into 1 into the denominator values are nothing but 2 into 2 into 2 into 2. If I simplify, 3 gets cancelled. This becomes 332 divided by 315. This now we converted this first kind of improper integral in terms of first beta, then beta is converted in terms of gamma. Why? There n is not a positive integer. Let's go with one more problem. In this in the previous module also I explained how to evaluate a gamma functions. Look the example problem here. Previously I discussed about integral 0 to infinity e power minus x square into dx equal to root pi by 2. Using this gamma definition, I am going to apply to show this function. Let us take this function. What is the function? Show that integral 0 to infinity x power 4 e power minus x square into dx equal to root 3 pi by 8. Let us take the given function integral 0 to infinity x power 4 e power minus x square into dx. This is second kind of the improper integral. For this integral, already I explained, you must understand the definition of the gamma function. What is the definition of the gamma function? Gamma of n equal to integral 0 to infinity e power minus x power n minus 1 into dx. This is the definition. This is a single variable function. N is always greater than 0. Let us take here, we need to convert x square function wherever x square is there. Let x square equal to, let us assume t. What happens? X is equal to t power 1 by 2. What is the derivative of this function? Dx. Dx equal to 1 by 2 t power 1 by 2 minus 1 into dt. Therefore, dx is equal to 1 by 2 t power minus 1 by 2 into dt. Wherever dx is there, I can substitute 1 by 2 into t power minus 1 by 2 into dt. Let us take this function, the given integral. Let us write this integral value x. X is replaced by how much now? X is replaced by t power 1 by 2. And power is how much? Whole power 4. And also e power minus x square is there. X square is replaced by what? T. And dt. dt is replaced by what? 1 by 2 t power minus 1 by 2 into dt. Let us come back with the limits of this function. If I take this x equal to 0, we need to convert what? T limits. X equal to 0. If I substitute x equal to 0, what is t value? T value becomes 0. Similarly, x equal to infinity, then t is also becomes infinity. Therefore, this integral varies from 0 to infinity. Let me simplify this integral value. Integral 0 to infinity t square into e power minus t 1 by 2 t power minus 1 by 2 into dt. Let us take the constants outside. Integral 0 to infinity e power minus t power 2 minus 1 by 2 into dt. Let us take this value 1 by 2 into integral 0 to infinity e power minus t, t power, this becomes 4 minus 1, 3 by 2 into dt. See the definition of the gamma function. The definition of the gamma function, what is the definition of the gamma function? Gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx. Therefore, I am going to compare e power minus x is here is in terms of t. Therefore, n minus 1 is equal to 3 by 2, n minus 1 equal to 3 by 2, n equal to 3 by 2 plus 1, therefore, n equal to 5 by 2. This whole integral becomes 1 by 2 into gamma of 5 by 2. Therefore, 1 by 2 into, how do we calculate gamma of pi by 2? Root 3 by 2 into 1 by 2 gamma of 1 by 2. Therefore, 3 by 8 into gamma of 1 by 2 how much? Root pi. Therefore, 3 root pi by 8. This result becomes 3 root pi by 8. Now, I hope this understand about the concept. Wherever the functions are coming like x square or even though x cube, even though x power 4 or here x power 8, whatever it is, the improper second kind of the improper integral is transformed into the single variable function which is using by definition of gamma function. Let us go with one more example problem. Here it involves in previous function, it involves in the functions of exponential. Now we are including the function as a logarithmic function. This is also a first kind of the improper integral. See here in this example, evaluate integral 0 to 1 x power 4 log of 1 by x into x cube dx. We need to evaluate this is in terms of what? Logarithmic function, or I can say this function show that is 3 factorial by 625. Let us take this function. See, this function is in the form of, we need to convert all the values, whether it is, now we can't identify. In previous question, we can identify the given function is a gamma function, and that earlier function I converted in terms of first beta. Beta is converted in terms of gamma function. Let us take this integral value, integral 0 to 1 x power 4 log of 1 by x whole cube into dx. See here, we must understand the concepts of the gamma function definition. Whenever we are transforming one function to another function, we must clarity about that whether the function is in a gamma function, whether the function is in a logarithm, it is a beta function. Let us take this function, let assume that log of 1 by x is equal to t. Let us assume this function I am treating as some variable as t. Therefore, there is a base is always e, I can rewrite 1 by x is equal to e power t. I removed the logarithmic function by just e power minus. I can rewrite x is equal to e power minus t, because 1 by x already reciprocal of this value. I can take the derivative dx minus e power minus t into dt. Already the derivative of e power minus t. What is the derivative of e power minus t? E power minus t by into t. There is a minus 1. Now, I am going to substitute entire values, all whatever the values are present, what I assume all these values I can substitute in this integral value. Now, this integral becomes, I am not going to talk about the first limit, I am going to substitute the function. Let me substitute x. What is meant by x? X equal to e power minus t. Power is how much? Whole power 4. And log of 1 by x. Log of 1 by x is replaced by t. Whole power how much? 3. And dx is also replaced by e power minus t into dt. Okay, I think this is clear about the substitution. Let me talk about the x limits. For this function, x is 0. Now we transform these limits into the t limits. What happens if I substitute x equal to 0 here? This function is an undetermined value. T becomes how much? Infinity. And similarly, if I substitute x equal to 1, then it goes to t tends to 0. T tends to what? 0. You must understand the concepts of x equal to 0, the t limits becomes infinity, x equal to 1, then t limits becomes infinity. Now look this, I am going to write what is the lower limit? Infinity, upper limit becomes 0. Already you know the property, if there is any negative sign, I can interchange the upper limit as well as the lower limit. Now I can rewrite this integral 0 to infinity. This becomes e power minus 4t t power 3 into e power minus t dt. Now let me simplify this integral value. Let me simplify this integral value. E power minus, here is minus 4t, e power minus 5t t cube into dt. Now our single improper integral transformed into two variable improper, second kind of the improper integral. For this integral, we need to evaluate this value in terms of what? Gamma. Let me write the definition of gamma. What is the definition of gamma of n? Integral 0 to infinity e power minus x, x power n minus 1 into dx. See here, whenever we are taking such a integral values, there is a coefficient is minus 5. Let me take one more variable, put 5t is equal to some variable u, or you can assume any other variables also. What is t value? T value becomes what? T value becomes u by 5. dt is equal to du by 5. Now this integral becomes 5t becomes e power minus u, t becomes u by 5 whole cube, and dt replaced by du by 5. Let me go with their limit conditions. If the t limit is 0, to u limit is also 0, because if I substitute t value 0, u is 5 times 0 is 0, and t limit is infinity to u limit is also becomes infinity. Now this integral becomes 0 to infinity. Let me simplify this one. Here is 3 power 5, 3 power this one, this becomes 5 power 4 integral 0 to infinity e power minus u t power u power 3 into du. This becomes 1 by 625 into this integral value. I can rewrite, compare with this value, n minus 1 is equal to 3, n equal to how much? 4. I can write gamma of 4. How much? Gamma of 4. What is gamma of 4? 3 factorial by 625. Now we converted, whenever there is a logarithmic function, let me treat it as some variable, then we converted into the function, into the gamma function. The gamma function is a single variable function. I converted into the 3 factorial. I hope now it is clear about the basic concepts of beta as well as gamma. At least you must understand the concept of definition as well as the properties. Okay, let me go with very important concept, because most of the time we didn't prove. Always we are saying the beta function is a 2 variable function. We are converting into the single variable function to evaluate whatever the beta and gamma values. Here there is a important result about the proof of the relation between beta and gamma. I hope now this is very interesting concept, and prove the results also. Okay, let me go with the what is the relation between beta and gamma function. Beta of m comma n equal to gamma m divided by gamma of m comma n, where we are treating beta m n values. Already we know, even positive integers are functions such a values are present, we can evaluate directly. Even though the function values are in the form of fractionals, such a cases we are using beta values into the gamma values, because gamma values we can calculate for all positive integer values, negative integer values except 0. Okay, this is about the relation between beta and gamma. Okay, now let me prove the result of beta and gamma. Okay, before proving the this is the relation between beta and gamma. What is the relation between beta and gamma? Beta of m comma n equal to gamma m gamma n divided by gamma of m plus n. See, we need to prove this result. We must understand some basic definitions of beta function, some definitions of gamma functions, and also some properties of called beta function in the form of integral functions. Okay, let me go with the proof. Let me define gamma of m. I am going to define, let me define first the function gamma of m. What is gamma of m? Integral 0 to infinity e power minus x power m minus 1 into dx. This I defined in the form of gamma n. I am going to substitute some variable x is equal to y into t. I am going to substitute x is replaced by y into t. What happens? Derivative of this function dx equal to y into dt. Wherever dx is there, I can replace it by what? Y into dt. Let me go with the gamma of m integral x is replaced by how much? Y into t minus y into t, and also x is replaced by yt whole power m minus 1 into y dt. Now I am going to substitute lower limit x is 0. What is the t variable? T variable also 0. If x is infinity here, t value becomes infinity. Let me simplify this integral value. Integral 0 to infinity e power minus y into t, y power m minus 1, t power m minus 1, y into dt. Now compare the y variables. Let me compare the y variables. What happens? Integral 0 to infinity y power minus e power minus y into t and y power m t power m minus 1 into dt. Now look, this is the variables of t. It is not depends upon the values of y. Therefore, this value I can rewrite gamma of m divided by y power m into integral 0 to infinity e power minus y into t power m minus 1 into dt. See, now I can replace right hand side of this integral value. I can rewrite in terms of x or in terms of t. Let me write gamma of m divided by y power m integral 0 to infinity e power minus y into t x power m minus 1 into dx. Now this is the standard integral. For this standard integral, we need to multiply certain quantities and we can identify the resultant value. Let me go with one more slide. What is the final equation I got? Gamma of m by y power m is equal to integral 0 to infinity e power minus y into t y into x e power minus y into x power m minus 1 into dx, equation 1. For this equation 1, I can multiply with e power minus y power m plus n minus 1 on both sides. I am going to multiply both sides by what? E power minus y power m plus n minus 1. And also I am integrating and integrate both sides with limits y equal to 0 to y equal to infinity. Let me write the left hand side of the function gamma m by gamma n, integrating where to where? Integral 0 to infinity. What are the multiplication? E power minus y power m plus n minus 1 into what? dy. The right hand side also similarly, integral 0 to infinity e power minus yx x power m minus 1. What are the multiplication? E power minus y power m plus n minus 1 into multiply dx. There is a dx as well as dy. There is a one more integral 0 to infinity. Now look this integral value. Look this integral value e power minus y. Now let me simplify first left hand side of this function. There is a gamma m. Gamma m is a constant, and also y power n also removed. How can I write this one? Can write like this: integral 0 to infinity e power minus y power n minus 1 into dy. Okay, I hope now this is clear, because y power m simplified. Here is integral 0 to infinity. Already you know the double integral. We are interchanging the x limits into the y limits into x limits. Therefore, integral 0 to infinity e power minus y is common x plus 1 into e power x y power m plus n minus 1 into dy into x power m minus 1 into dx. I rewrite the variables of x limits as well as the rewrite the y variables. This left hand side becomes gamma m into gamma n. Here this entire value I can rewrite integral 0 to infinity gamma of m plus n into x power m minus 1 into dx divided by 1 plus x whole power m plus n. 1 plus m plus n. Now, how do you get this result? Now, you have some doubt about in the particular case. See, use this equation 1. Use the equation 1. If you substitute m replaced by m plus n, this becomes this integral value. Therefore, what are the common now? Gamma n divided by gamma of m plus n, which is equal to integral 0 to infinity x power m minus 1 by 1 plus x whole power m plus n into dx. Already you know the definition of the beta function in the form of integral. Already we know beta of m comma n equal to integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx, which is an integral form of the beta function. Now, this left hand side becomes beta of m comma n. Therefore, gamma n divided by gamma of m plus n. Now, we proved the result about the relation between beta and gamma. Let me go with the simplest form. How do you, once I will repeat this relation between beta and gamma function. See, wherever the beta functions are there, beta can be converted into the single variable function gamma. Whenever we need to prove the beta gamma relation, let me define first gamma function. Definition of gamma function, gamma of m. After substitution of definition of beta and gamma, I substituted x is replaced by y into t. I can converted x in terms of y's. Therefore, that integral becomes gamma of m by y power m into integral 0 to infinity e power minus y into t x power m minus 1. For this equation 1, I can multiply both sides by e power minus y power m plus n minus 1, and also integrating 0 to infinity on both sides with the variable of y. For that, I can interchange the we can interchange the order also, order of the integration. You have familiarized by, because further courses you can understand what is the change of the order of the function. I changed the order in terms of y in terms of x. Then this integral becomes integral 0 to infinity gamma m plus gamma n divided by 1 plus x whole power m plus n into dx. Further, I used the definition of beta function. In terms of gamma, I can express integral form, which is beta of m comma n. What we proved now, beta of m comma n equal to beta of m comma n is equal to gamma m gamma n by gamma of m plus n. Most of the times they may not use always m and n, they may use in terms of p and q, or I can rewrite beta in terms of p comma q, gamma p into gamma q whole divided by gamma of p plus q. Both the result are the same. I hope now it is clear about the relation between beta and gamma. First we need to define gamma m value, substitute x equal to y into t. Then you convert into the equation 1, gamma m by y power m is equal to integral 0 to infinity e power minus y into x power m minus 1 into dx. Further, the equation 1, multiply both sides by e power minus y power m plus n minus 1, and also integrating both sides with respect to y from 0 to infinity. Further, we can simplify the result, which is beta is converted into the gamma. Let us go with one more final topic about the duplication formula. Most of the times already you understand about the definitions of beta function. Beta function we are converting into the gamma. Even though we are converting, that value we can't evaluate such a simple manner. Such a cases we are going to use duplication formula. The duplication formula is given here. Duplication of formula is nothing but gamma of n, gamma of 1 minus n is equal to pi by sine n pi. This is called duplication formula. Most of the times already I recall back about the functions. Wherever we are converting the functions beta into the gamma, not such a simple manner. Even though sometime we can't evaluate such a values, we need to convert into the duplication formula. There is a duplication formula here. Prove that the gamma of n into gamma of 1 minus n, which is pi by sine n pi. Okay, I am not going to give much stress about the proof here. See, this n, wherever n is there, we can substitute here n value, we can calculate some trigonometric function. This actually duplication formula convert natural number system, even though negative integers or positive integers except 0. We need to convert, we can't convert such a values, we can convert in terms of trigonometric values. This is called as a duplication formula. See, we need to prove this result. We must have understand about the definition of beta function, which is in the form of an integral function, as well as the relation between beta and gamma. Already we proved that the relation between beta and gamma equal to gamma n by gamma of m plus n. Okay, let me go with the proof of this function, proof of this duplication formula. Because this duplication formula not as much as simple, because this is taken from the what you call long calculus, which is in the form of cosecant functions. See here, gamma of n, gamma of 1 minus n equal to pi by sine n pi. First, I am going to define the beta function. Beta function in the form of what? Integral value. What is integral form of beta? Beta of m comma n is equal to integral 0 to 1 x power integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. Okay, and also we know the relation between beta and gamma. What is the relation between beta and gamma? Beta gamma m, gamma n by gamma of m plus n. Now, this is equation 1 and equation 2. When we compare both equation 1 and 2, this becomes gamma m, gamma n by gamma of m plus n, integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. Let me substitute, let me take m plus n is unity. Most of the times we are assuming m and n are integer values even though their sum values is equal to 1, because already in the duplication there is a integer n. N is means what? One value, variable value is fixed values. Therefore, m plus n equal to 1, I can return m is replaced by 1 minus n. Now this becomes what happens? Gamma relation value becomes gamma, it becomes gamma m, gamma n, gamma of 1 minus n divided by gamma of 1 integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. What is gamma of 1? Gamma of 1 is 1. Now left hand side becomes gamma n, gamma of 1 minus n integral 0 to infinity x power n minus 1 by 1 plus x into dx. Already m plus n value becomes how much? M plus n value becomes 1. See, for this result, this value becomes 1. For this result, we need to prove by based on the calculus integral 0 to infinity x power 2n 1 plus x 2n into dx equal to 2 pi by 2n pi cosecant 2m minus 1 plus 1 by 2n into pi. Actually, using this result, we can rewrite this is nothing but what? Pi by sine n pi, gamma of n, gamma of 1 minus n. What is gamma of n into gamma of 1 minus n? See, with this duplication result, we are going to take one example problem to evaluate such a duplication formulas. See, already I told most of the time we are converting beta into the gamma function, gamma m, gamma n divided by gamma of m plus n. Even though the denominator values are becomes 1, but even the numerator values are can't evaluate such a integral gamma values. In such a cases, we need to convert into the duplication formula. What is duplication formula? Gamma of n, gamma of 1 minus n is equal to pi by sine n pi. See here, gamma of 1 by 4, gamma of 3 by 4. How do you write gamma of 1 by 4, gamma of 1 by 4, gamma of 1 minus 1 by 4. Now I written 3 by 4. This 3 by 4 value can be written as what? 1 minus 1 by 4. Let me see the duplication formula is saying n into 1 minus n can be written as what? Can be written as pi by sine n pi. What is n value now? N becomes how much? 1 by 4. N is how much? 1 by 4. I am converting this into pi by sine n. N is 1 by 4 into pi. Therefore, pi by sine pi by 4. What is sine pi by 4? 45 degrees. Pi by, what is sine 45 degrees? 1 by root 2. If I simplify, 2 root 2 pi. I hope now this is clear about evaluation of the using duplication formula. Okay, what are the basic concept today we discussed in this session? We used most of the times single variable function. We are converted into the two variable function, which is in the gamma function. Further gamma function we can evaluate it by using the relation between beta and gamma, which is in the form of, this is called as the relation between beta and gamma. Further we evaluated there is an improper integral of second kind value. We converted in terms of gamma functions. Using with the help of the gamma function, we evaluated the second kind of the improper integral, and even though the function consists of a logarithmic function, we evaluated the such a integral values, and also we proved the relation between beta and gamma, which is gamma m, gamma n by gamma of m plus n, and also with the help of the duplication formula, gamma n into gamma of 1 minus n pi by sine n pi, we converted into pi by n pi. In such a cases, difficulty to evaluate gamma of certain values, such a cases we use duplication, which is gamma of 1 by 4 into gamma of 3 by 4. I hope now you enjoyed this class. Thank you.